Hey, everybody. Hope you're doing well. I've been interested in this longevity topic for a long time. I think most people are kind of, enamored by some research and some thinking around what we can do to live better, more effectively, and whatnot. And this piece, longevity, are we trying too hard? Was my main talk for this year. So most of the speaking events that I was going to attend, this is what I was going to present. So for a lot of you, I think a few folks saw it like at Metabolic Health Summit, but then with the COVID outbreak and whatnot, clearly that's curtailed live events. So I'm releasing this to everybody because I think it's really important. I think that folks are diligently trying to do things that they think are good for themselves. And I think that they may actually be possibly trying too hard. And I'm going to make kind of a big case around that. In 2005, I wrote the first intermittent fasting article that I had published for the Performance Menu. And it was looking at this potentiality that the right amount of intermittent fasting plus feeding could like double lifespan. It was in mice, which I should have taken a little bit more thought around the implications of something occurring in mice versus humans. I didn't know things at that time like genetic reaction norms, which we're going to talk about today. But the long and short of that, I didn't have mice listening to or reading the article that I provided. I had people doing it. And I released that in 2005. And by 2006, I deeply regretted releasing that article because I was earlobe deep in the CrossFit scene, and for a variety of factors, the extreme personalities that tend to be drawn to CrossFit, it lent itself well to taking the fasting idea to a pretty good extreme. And I started getting reports from people that were like, hey, my hair's falling out. I haven't had a menstrual cycle or an erection, depending on where you're at on that spectrum, for 6 months or a year. My performance has been retrograde. And when I started digging into what these folks were up to, they had eaten 5 grams of carbs a month for the last year. They intermittent fasted for 20 or 21 hours a day, virtually every day. They did CrossFit 6 days a week, but don't worry, they did recovery jogs and hot yoga on their time off. And so I found some situations in which some intermittent fasting was pretty favorable, usually more type B folks, desk-bound, sedentary, and it worked okay. It seemed to be beneficial, and if nothing else, it simplified folks' lives. Like if they shifted from the standard paradigm of eat like 4 to 6 meals and snacks a day down to 2 meals a day. Typically they ate less food, so they had some spontaneous caloric restriction, and it just simplified their lives. They had less cooking, less cleanup, all that type of stuff. So, there were benefits in there, but it at best, it was like a 60-40, 70-30 that seemed to be negative versus positive. And again, this is tough to reconcile because we're just buried under research that suggests that fasting is great and it's so beneficial. Calorie restriction, Walter Longo, lots of people, beating the drums of these different approaches of protein avoidance, calorie restriction, intermittent fasting. And I guess if you want the TLDR, the too long didn't read version of this, the case that I'm going to make is that once we hit something that looks like ancestral eating and you're getting adequate protein, you're not overeating, you find a carbohydrate intake level that works for you, a la Wired to Eat, and some personalized nutrition, I'm not at all convinced that there's any upside to much of any amount of calorie restriction, protein avoidance, or fasting. So that's kind of the long and short of it. If you, or that's definitely the short of it. If you want the longer part, then we're going to start digging into that now. So clearly humanity has been fascinated by longevity. And when I started thinking about doing this talk, I wanted to see what were some of the earliest examples of people digging into longevity, trying to figure out ways of modifying how long they were going to live. And it was interesting. It's a little bit I don't know if it's quite foreshadowing for the stuff that I'm going to talk about, but the Chinese alchemist elixir poisoning is really interesting. These, incredibly powerful individuals, emperors of China, would consume things like arsenic and mercury that were supposed to provide longevity, and it ended up clearly shortening their lives. And I'm not going to say that calorie restriction, protein restriction, and fasting are on par with mercury and arsenic, but it's interesting that we have some things that I think are well established, but not particularly sexy with regards to improving longevity. And when we think about longevity, we need to think about several different things, not just the duration of life, but the quality of life, what we're really calling health span these days. And we have some fairly tried and true things, but they're just not sexy. They're not a hack. There's, it's not like peddling underwear that protects your junk from EMF radiation and stuff like that. So people don't get that excited about it, and they keep looking for some sort of a shortcut. But what we're going to dig into is that there are some really specific concerns. And I also recognize that some people are going to have the benefit of seeing the slides that go along with this presentation. Some people are going to be listening to this via podcast. I will do my best to describe the research articles that we're going to cite later, and the bulk of that should end up in the show notes, so you will be able to dig into that stuff. But there's some real concerns that pop up for people within, let's say, this ancestral health scene, paleo, keto, low carb. And the big concerns are that a high protein diet will accelerate aging, it will activate Mtor, it will stimulate insulin, and you will be drowning in insulin-like growth factors, and that net, this is going to shorten your life. And there's some kind of compelling research around this, where particularly in animal models, when they reduce the protein signaling, the insulin signaling, the expression of various growth factors, these animals tend to have less disease. They tend to live longer. So it's really compelling, but again, there's a lot of details that need to be considered there. And I don't see, I was going to say enough people, I don't really see anyone tackling this subject the way that I'm going to present today. And that doesn't mean that I'm right, but there are some things that we're going to dig into, like the cell senescence cycle and autophagy, the Hayflick limit, that some really, really well-known, very popular people who go on and on and on about longevity, they don't talk about these things at all. And this, in my opinion, is an absolutely glaring hole in the game that they are playing, and in their ability to really understand this from kind of a macro level. So, what's being recommended for folks is some degree of calorie restriction. Historically, this has been called CRAN, and that's what I'm going to call it today. CRAN stands for Calorie Restriction Adequate Nutrition. That term has kind of fallen out of favor of late, but I like it. Another thing that's definitely being recommended a lot is extended periods of fasting, anywhere from 24 hours to 10-day fast. And again, there might be certain circumstances in which that may be appropriate and may be a good thing, but I have some legit concerns around how often one should do that. And again, once we reach a point of relative leanness, of decent appetite control, I'm not sure that extended fasting is giving us all that much relative to lifting some weights, getting a tan, and drinking a cup of coffee, but I'm going to dig into that later. And maybe the worst part of this is the recommendation for really overt protein avoidance. And what's interesting for me on this is that there are folks within the ketogenic diet world that are recommending protein intakes that are on par with what a raw vegan would recommend. And it's worth mentioning there are folks that are pretty popular, have pretty good followings, that are out in the keto space, and they recommend a total of 30, 40 grams of protein a day. If you follow the 30 bananas a day diet, one banana has about 1.5 grams of protein. Now, granted, it's not a complete protein and all that type of stuff, but if we just go total amount of protein. If you eat 30 bananas a day, you're up around 40 grams of protein. This is maybe a pretty biased way to look at this. Maybe it's kind of almost like a straw man type attack, but I'm going to say that if you are recommending a ketogenic diet, an ancestral approach to eating that consistently looks like the recommendations from a macronutrient perspective that the raw vegans are making, there's going to be a significant problem there. And again, folks are welcome to do whatever the heck they want to do. But if you're really getting suboptimal results, if you don't have good body composition, like this, again, this is an observational thing. It's maybe kind of a prickish thing to say, but I'm starting to notice where within like the paleosphere and the ketogenic diet world, people usually looked pretty fit, pretty robust. I'm starting to see people that are gaunt and sarcopenic, and they just look kind of used up. And they tell me, oh yeah, I just wrapped up my 7-day fast and I'm barely eating any protein. And, you know, they're doing this with the thought that they're going to extend their life. They're going to reduce their likelihood of cancer and a host of other things. And as we're going to discuss later on, there are trade-offs to everything. And who knows, maybe there is some significant upside to doing this stuff. I'm not sold on that. But something that folks do not appreciate is that there absolutely is a trade-off with everything. Every choice we make doesn't just have upside. Maybe calorie restriction and protein avoidance has some upside, but it has some downside too. And I just don't see enough people really talking about the potentiality of some of those downsides. So in the caloric restriction research, it goes all the way from nematodes to fruit flies to some examples of critters that are a little bit closer genetically to us with regards to primates. And I've got an example here of a study that looked at a couple of rhesus monkeys, Kanto, who's eating a calorie-restricted diet, and Owen, who's eating kind of a normal ad libitum diet. And the infographic kind of describes Kanto's diet as being much more nutrient-dense, like when they represent the human menu. And I'll circle back around to this, but the ironic thing is the diets fed to these monkeys are lab chow. It's basically these compressed pellets of seed oils, dense carbohydrates, usually some sort of completely non-species appropriate protein source, like a whey protein isolate or something like that, and then they each get an apple a day. But I'm going to circle back to that. But without a doubt, in these animals, the animal eating less calories seems to be faring better. He has less disease and is at a lighter weight by all outward observations, appears to have, less signs and symptoms of aging. One of the most prominent people or figures in the CRAN or calorie restriction scene on the human level is a guy, Roy Walford. And Roy was pretty famous for his work within the Biodome Project, where they had folks that were trying to live within a self-contained environment and grow their own food and deal with all the challenges of having a self-enclosed ecosystem. And part of the idea around this was doing some research that could be parlayed into maybe a moon base or a Mars base or something like that. But it's worth mentioning that, unfortunately, Roy Walford died in his late 70s. Like he barely made it past average lifespan. And he died from a type of amyotrophic lateral sclerosis, Lou Gehrig's disease, neurological deterioration. And here's an interesting thing that we need to think about with regards to calorie restriction versus something like a ketogenic diet. So I'm going to do a little bit of reading here. This one's actually from Wikipedia. Previously, Peterson and Mattson. Mattson is a famous calorie restriction researcher, fasting researcher also. But Mattson found that in the ALS model for mice, calorie restriction accelerates the clinical course of the disease and had no benefits. suggesting that a calorically dense diet may slow ALS. A ketogenic diet in the ALS mouse model has been shown to slow the progress of the disease. More recently, Matson et al. Opined that the death by ALS of Roy Walford, a pioneer in the calorie restriction scene, and its anti-aging effects may have been a result of his own practice of calorie restriction. Moreover, as Matson et al. Acknowledge, Walford's single case is insufficient to establish the proposed cause and effect relationship. And even Walford himself speculated that it may have been caused by a combination of his very calorie deficient diet. And it's interesting when you look back at the type of things that Roy was eating, like bran muffins featured prominently in his story. You could really make a case that if you were to undertake some sort of a calorie restriction type approach, like a ketogenic diet, lots of things like broccoli and spinach and stuff like that would have been much more nutrient dense. But it's interesting. This paper from the British Medical Biomed Central, ketogenic diet as a potential novel therapeutic intervention in ALS. And from that paper, this is the first study showing that diet, specifically a ketogenic diet, alters the progression of the clinical and biological manifestations of the G93A superoxide 1 transgenic mouse model of ALS. These effects may be due to the ability of ketone bodies to promote ATP synthesis and bypass the inhibition of complex 1 in the mitochondrial respiratory chain. So if any of you have seen my previous talks, I believe it was my metabolic flexibility talk, I talked about the reality that if we tend to be more fat-centric in our metabolism, we tend to put more of our energy through the complex 1 mitochondrial chain, and that is significant in that we have a lower reactive oxygen species load on our person. And it's worth mentioning in that story that people that are very metabolically flexible, people that are very insulin sensitive, even when they eat higher carb diets, what ends up going through the respiratory chain in this situation still tends to mainly be fat. And so a metabolically flexible, metabolically healthy person, even eating a higher carb diet, handles that food in a different way than somebody who is less metabolically healthy. And the significance here is that this reactive oxygen species, this oxidative load, ends up causing genetic damage, protein damage, but there's kind of two pieces to this energy story. And if you look into ketogenic diets, one of the big upsides, the benefits that they have is that they are ketone bodies are kind of, in addition to being described as signaling molecules, they're also an energy rescue molecule option. And what's interesting is when folks are not particularly metabolically healthy, they can damage neurological tissue in particular in two kind of interrelated ways. They can damage neurological tissue with a very high blood glucose level, where the blood glucose levels go quite high and the cells are just inundated with energy. And that inundation with energy itself causes significant oxidative stress. A lot of that energy goes through complexes other than complex 1 in the mitochondrial chains, which cause more reactive oxygen species. So you get some damage on the upside of advanced glycation end products, oxidative stress, a number of different factors. But then on the downside, when we head into a hypoglycemic state and we're insulin resistant, we do not access fat particularly efficiently. We do not produce ketone bodies particularly efficiently. So these neurons that maybe suffered an insult of excess calorie exposure are now in an energy crisis. And if we don't have the ability to shift into ketone body metabolism, then these neurological tissues effectively die. And again, they can be damaged in this kind of repetitious cycle of hyperglycemia to hypoglycemia. And this is also possibly why just figuring out some sort of a dietary approach where the blood sugars don't go that high, they don't get that low. We maybe have some backup fuel options like ketone bodies or just more directly being fat fueled. These things may be incredibly beneficial. And again, from a host of different directions, reducing advanced glycation end products, reducing oxidative stress, host of different factors. So one of my favorite papers is from Biogerontology. It was published in June 2006. It's called Calorie Restriction Does Not Enhance Longevity in All Species and is Unlikely to Do So in Humans. This is such an incredible paper. And again, it's something that I'm fascinated by, that the really vocal calorie restriction, fasting-centric folks out there in the world that are kind of selling a hope and a dream around this stuff, I've never seen one of them reference this paper. And it's fascinating to me. And what this paper unpacks is the reality that a calorie-restricted diet does enhance longevity in some species, but it by no means does in all species. In wild-type animals, it tends to not enhance longevity. In wild-type animals fed a species-appropriate diet, it actually curtails the relative lifespan. And again, this is some really important stuff. Like noodling on what's a species-appropriate diet should be one of the first whistle stops that we make when we're considering health and wellness and longevity. Yet it's not really discussed at all within the popular circles in this scene. So going back to that example of Kanto and Owen, the two rhesus monkeys, one on an ad libitum diet, the other one on a calorie-restricted diet, what this paper from Biogerontology really suggests is that calorie restriction is nothing more than defense against a terrible diet. And that kind of makes sense on some level. If eating less of a bad diet would probably be more beneficial than eating more of a bad diet. Because again, these animals are fed a concentrated lab chow, which some of the recent research, which this is new enough that I haven't updated it into this talk, but the Kevin Hall research looking at ultra-processed diets, people and animals spontaneously consume more food. And that shouldn't be all that surprising, but it's even when they really worked to try to calorie match a less processed versus a more processed diet, people got sick. People had metabolic problems. So yeah, calories are important, but at some point the refinement of the diet becomes so onerous that the only defense is eating less of it. But if we're not eating a terrible diet, the benefits of calorie restriction appear to kind of evaporate. And this is where digging into the research looking really deeply at species-appropriate diets, and ironically, there's not that much out there. You would think, again, that this would be one of the first whistle stops that we would do. We're going to look at mice and their health and whatnot, and so maybe we feed mice the things that they eat, like wild nuts and seeds and bugs and, grasses and stuff like that. The problem there is that nutrition science, trying to be a science, we need to have some accuracy and precision in what we're doing. And that's fine. That's reasonable. But what that has led to is that in an effort for researchers to know exactly what animals are eating, it's much more amenable to feed them a pelletized food that we know down to like the picogram, how much protein, carbs, fat, vitamins, minerals are in this pellet. And then we can see how much of the pellet the animal ate. And so it really lends itself well to that. But the few studies that are out there that look at feeding critters a species-appropriate diet, these animals don't live as long when calorie restricted. Calorie restriction in the wild is a death sentence. Animals living in the wild have to, by hook or by crook, find at least a modest calorie excess. And this is due, for a lot of reasons. And actually, Art Devaney had a paper ages ago looking at kind of the modeling around this and makes the case that, yeah, we shouldn't overeat every day all the time, but on net, trying to undereat is going to mean a shorter life. So another thing that's really important in this story, people might be asking, well, why is this not the case? Particularly for humans, there, again, are some examples of certain critters that seem to benefit from calorie restriction with regards to reduction in disease process and also in total lifespan. Again, this is kind of, there's some interesting push and pull on this, though. This might be completely an artifact of just feeding animals a terrible diet and the fact that a calorie-restricted diet ends up benefiting them. But another piece of this story is something called a reaction norm, or a norm of reaction. And this is, again, one of these topics that the longevity experts that are quite popular, I never hear these folks mention this topic. And what a reaction norm is, and I'm going to provide some resources here, but there are some things, again, like the Hayflick limit, genetic reaction norms, cellular senescence, that I really encourage you folks to take the references that I have with the show notes on this material and dig in deep, because I'm really of the opinion that those are the things that are going to better inform what we should be doing versus someone who's peddling a 500 calorie a day diet as part of a fasting mimicking protocol. That might benefit some people relative to overeating, but the hope and the dream that's being carried with some things like that, I think are actually not well supported by the science, particularly in the context of species-appropriate diets and all that stuff. But again, so a genetic reaction norm in ecology and genetics is called a reaction norm, also called a norm of reaction, describes the pattern of phenotypic expression, the way something looks or manifests, of a single genotype across a range of environments. What the heck does that mean? We arrive, or all critters arrive, with a certain genotype. And then depending on what the environment throws at us, this can manifest in different phenotypes. And the genetic reaction norm within the context of longevity, it suggests that if there is a steep reaction norm, steep and upward, that there's generally a favorable association between calorie restriction and longevity. But if the reaction norm is flat or decreasing, then there's no linkage between calorie restriction and this genetic reaction norm, which again is the outward manifestation of genes interacting with the environment. And in this case, the environment is effectively the food that we're eating, both the amount and the quality of the food. So in a scenario like with some animals in which child rearing is highly energy intensive, there is a tendency for CRAN, for calorie restriction, to trend towards higher longevity. And the basic idea with this is that an animal that is subjected to comparatively high caloric stress, nutrient stress, if it's in this kind of favorable genetic reaction norm story, calorie restriction is going to almost put them in almost kind of a state of suspended animation. Not exactly, but they're not going to age as fast. They're going to become cooler. They're going to become more lethargic. They're in an energy conservation mode. And the idea there is that hopefully they can wait until they hit a point later when the nutrition is more ubiquitous and favorable. They can reproduce and be successful. And even though I have 2 kids and I feel like the energy output for raising 2 kids is remarkably high, in humans, comparatively, our net energy input in raising offspring is not that high. And so we shouldn't really expect that calorie restriction would provide a net benefit for us. And the first time I saw this, it was alluded to in that paper talking about calorie restriction does not enhance longevity in all species, and this is where I learned about genetic reaction norms, and then followed those rabbit trails to some additional resources. This is another one from biogerontology. Caloric restriction increases longevity substantially only when the reaction norm is steep. And from that paper, our previous work estimates that the dietary reaction norms of rodents and humans have diverged substantially, with a very flat dietary reaction norm for human longevity. These general principles and our specific results suggest that the benefits from human calorie restriction would be minor. Now, I'm going to really unpack how minor that is. And again, what is the cost potentially versus the benefit of overt calorie restriction in humans? So this another paper from the Proceedings of the Nutrition Society Conference on Nutrition and Healthy Aging, Plasticity of Lifespan, a Reaction Norm Perspective. Actually, I'm not going to dig into this one a ton, but it just makes the case that, what's my point with this? The point with this paper that I found really important is it explains genetic reaction norms and how the genotype can be expressed differently based off of environment. And the lifespan can depend on a lot of different factors that become independent or decoupled from calorie restriction. And again, this is another great paper. Does calorie restriction extend life in wild mice? And the answer to this is generally no. They don't express it. The female mice showed a modest improvement in longevity and health. But what was really interesting is that the wild mice tended to spontaneously eat less. And what this paper suggested is that this enormous juggernaut of animal-based research has basically bred these animals to be both sick on the diet that they eat and to overconsume food. And so they've effectively, you could make the case that these animals could have been selectively bred in a way that they were more protected against disease, but they weren't. So lab mice relative to wild type mice tend to eat, lab mice eat more. They have a tendency to overeat. The wild type mice tend not to. And interestingly, we don't really see much in the way of calorie restriction benefit in these critters. And so this again, we'll get into a little bit of the mechanisms like insulin-like growth factors and whatnot. But again, if we're thinking about this, for what do we take away for ourselves, just some thought around a species-appropriate diet is probably a pretty good idea in this context. Another paper, targeted disruption of growth hormone receptor interferes with the beneficial actions of calorie restriction. And what this was is looking at growth hormone receptor knockout mice saw no benefit to calorie restriction. And this is because the growth hormone receptor knockout mice didn't see an additional improvement in insulin sensitivity. This is one thing that does occur in the calorie-restricted individual, is that we see an improvement in insulin sensitivity. And the flip side of that, we could really say, is just a decrease in total insulin flux, the production and expression of insulin. That's interesting, because we have ways of modifying that story that I think are pretty favorable, and maybe don't carry some of the downside problems of these other, kind of elements. Another paper, Evolution of Human Longevity, Uncoupled from Calorie Restriction Mechanisms. And again, this is just kind of supporting this whole story. The nuts and bolts of this, or the nitty-gritty, is that the transcriptome of humans, the proteomics that are expressed in humans, look more like that of ad libitum-fed mice. So our longevity is largely decoupled from calorie restriction pathways. We might get a mild effect, but, we might have better options that we can pull together on this. So I know that's a ton of stuff. Like each one of these topics, genetic reaction norms should have had a 1-hour talk on that. Cell senescence should have a 1-hour talk on that. I may circle back around and do expansions on this stuff if folks are interested. But to pull this whole thing together, I had to cover a lot of ground, cover it kind of quickly, and then kind of, just paint the picture that I'm painting. But what does all this stuff mean in practice? Like if you were to apply calorie restriction the way that we hear we're supposed to do to experience great benefits in longevity, what does that mean for you? To get the most from calorie restriction, you would need to, from childhood, eat 40 less than what you normally would ad libitum. And this would leave you cold, hungry, tired, hypogonadic, no sex drive, and sarcopenic. You blow muscle mass. And this is just a known thing. And this all might, the best estimates, and this again circles back to that paper, not calorie restriction does not extend lifespan in all organisms. The best estimates are a human being enacting calorie restriction from childhood, writing it out their whole life, is you might get an additional 6 years of life. So best case scenario, you might get a bit less than a 10% bump in total lifespan, which is non-trivial, but the whole time you're alive, you're going to be miserable. But there's some other options out there. There are some things that work maybe as well or better than calorie restriction, and I would argue that they suck a lot less. So if we just, and also just really quickly, there's so much speculation around these topics of protein restriction and fasting and calorie restriction. And it's cool. Speculation is fantastic, but we have other things like what I'm going to talk about here that the science is actually really robust. It's really well known, and it generally improves our quality of life now and potentially improves the quantity of life that we have later. So this is part of the reason why I felt it so important to get this information out, because I see people with very good intentions doing some stuff that I think is actually going to be deleterious to them in the long haul. So a review article, Does Physical Activity Increase Life Expectancy? A review of the literature. And the takeaway from this is the conservative estimate of the net increase in life expectancy with physical activity is about 2 to 4 years, but presumably even greater because of the positive influence of physical activity on major risk factors for mortality. So if you were to live a, quote, normal life, again, figure out a way of eating in which you don't overeat, which is a non-trivial thing in a world of hyper-palatable, highly processed foods. But if you can figure that out and you maybe lift weights 2 days a week, 3 days a week, do a little bit of cardio or running around, you get some or all of the potential benefits that you would ever get from overt calorie restriction. And when people are talking about, we're going to dig into Mtor and some other things here in just a little bit. When people raise their hand and say, well, what about protein restriction? Calorie restriction is largely a story of protein restriction. It's also insulin management and stuff like that. But at the end of the day, folks are really looking kind of at protein restriction. In some cases, specific amino acid restriction like leucine, which I think is getting out in the weeds so far. It's almost painful. But anyway, we know that physical activity provides a lot, both today and later. And this is going to be really important when we talk about sarcopenia near the end of this presentation. The next paper, Association of Coffee Drinking with Mortality by Genetic Variation in Caffeine Metabolism. I will say that this is an epidemiological study. So, we love to beat up on that when it's painting meat in an unfavorable light. But what's really interesting about this is that higher coffee consumption was associated both with longer life, but also a worse lifestyle. Like there was this inflection point where more and more coffee tended to be associated with a shittier lifestyle. And despite that, it still trends towards an association with increased longevity. So if you like coffee, that's great. If you don't, maybe tea or something like that works. But again, this is something that when we see it buck the trend of being known to be associated with worse dietary practices, like when we account for that story with meat eaters, like the healthy user bias, when we looked at meat eaters that tend to buy their food from a health food store, we no longer see the negative association between meat eating and different disease states. Whereas it pops up in this epidemiological study that although increasing coffee consumption is also associated with a poorer diet, it still net seems to outperform the poor diet, which is really fascinating. Finally, sunbathing. Why do sunbathers live longer than those who avoid the sun? This is a Science Daily piece. And from it, we found smokers in the highest sun exposure group were at a similar risk as non-smokers avoiding sun exposure, indicating avoidance of sun exposure to be a risk factor of the same magnitude as smoking. When I found this one, it just blew what little hair I have left back. Like, again, this is something that's enjoyable, and I'm not suggesting that you go out and turn yourself into a leather handbag. There's a dose response curve associated with this. There's a great app called D-Minder, and it will take into account your skin type and eye color and whether you're a ginger or not, and then, you know, where you are on the planet, and it will kind of give you an idea of what is a reasonable sun exposure. And even in Central Texas, which can have quite intense sunlight, we're, you know, reasonably closer to the equator than where I've historically lived. On a really sunny day when the UV index is like 10 or 12, then my time out in the sun without putting on some clothes, I don't really use sunscreen, but I'll put on like a rash guard or something. It's like 20, 25 minutes per side. And so that's what I'm talking about. I'm not talking about trying to get a leather handbag effect out of this, but it's so well understood how important our circadian biology is and all of the knock-on benefits of sun exposure. And I have people really push back on this, particularly, you know, again, I remember it was when I posted some of these things on social media years ago, like the moms of gingers or the ginger moms, redheads, like they would just freak out about this stuff. And I'm like, exposure for your kid may mean 5 minutes, you know, and whereas with me, I have a fair amount of Native American in me, and it, you know, I tan up a decent amount and everything. And so my sun exposure may be significantly longer than someone else's, but there's still this case to be made for get the amount that is safe and reasonable for you. And we have some ways of customizing that, like I mentioned with the D-Minder. But again, we know smoking is so dangerous, but yet the risk of negative health outcomes of inadequate sun exposure is on par with smoking. That's just jaw-dropping. And it's something that we can easily take care of. And for the folks that are actually watching the video on this, a great slide, hot new wellness craze involved getting out there and just tanning your taint. So dropping your britches and getting some sun on your nether regions. I can't wait to see what Ben Greenfield does in this regard with products and services, but pretty interesting. So another really good paper that I may circle back and do a full unpacking of this because it's so important. It's such a valuable piece. It's from the International Journal of Environmental Research and Public Health. The title is How the Mid-Victorians Worked, Ate, and Died. And this is really interesting. It's a natural experiment in longevity. A natural experiment is a scenario in which a population has one particular factor changed. So there are some examples, like I believe there were some places in Montana where a couple of counties outlawed smoking in all establishments, but then the areas around them continued to allow smoking. And they saw a reduction in all kinds of respiratory related illnesses for both the smoking population because people smoked less, and more importantly to this study, the secondhand smoke to the folks that were exposed to it. And what was interesting is we had a situation where everybody smoked and then smoking halted in public enclosed places. And then this program was turned back and people were then again allowed to smoke. And then we saw the same prevalence reemerge of these diseases. And this is the case that the researchers make for this mid-Victorian piece. They talk about it, and it's so interesting, particularly relative to, say, kind of like the paleo diet narrative. Although the story is very similar, they spend a big chunk of the book educating people that, hey, there was a period of time when people were healthier than what they are now. And that may be surprising, but, here it is. And again, it's very similar to the paleo diet story. But what's interesting in this regard is we have birth certificates and death certificates and documentation, like people entering the military and how tall they were and what their physical fitness was, So it's honestly a much more robust picture of this whole process. And the snapshot or the story is this urbanized population was quite sick. They're living effectively in squalor. This is in pre-antibiotic era, pre-public health. This is before the germ theory of disease. I mean, it just people living on top of each other. And we had we had a populace that was eating a very nutrient-poor diet, mainly grain-based, not a lot of meat, not a lot of fruits, vegetables, seafood. But then the food quality dramatically improved. To some degree, the infrastructure, the distribution, the industrialization hit a point where people started eating significantly larger amounts of meat, fish, fruits, and vegetables. They still ate some grains, but it displaced these more nutrient-dense foods, displaced some of these like unleavened breads and stuff like that had historically been consumed. And keep in mind, this tracks a population over about a 50 to 80 year period. And what happened is they went from being relatively short, relatively unhealthy, relatively short lifespan. Their height and longevity increased. And what's interesting is when you dig into what these folks were actually eating, like in this presentation, I have a question. The mid-Victorians were calorie restricted and low protein, right? That's why they were healthy. Anything but. The energy needs of folks for the men were somewhere between 4,500 and 5,000 calories a day. Women were only a bit behind them because people worked absolutely prodigious amounts. Like, it was incredible the amount of work that people did. And here's an interesting thing, again, for kind of the protein-phobic people, the people that are really worried about Mtor, protein was 25 to 30% of the diet. And what that means is that women were getting 250 grams of protein a day, men were getting 300 to 400 grams of protein a day. But they were in fantastic shape and they lived as long as we do today within this window of time in which they had a particularly better diet. And again, no benefit of modern medicine, terrible sanitary practices, but their longevity was quite good. Then things changed. The industrialization kept ramping up, and this led to poor quality food, less fresh food, more canned food, more preserved food. People lost an average of 6 inches in height, and the military actually had to change its standards, had to reduce its height entrance standards by 6 inches because literally nobody was tall enough to get into the military, or far too few people. And there was a dramatic curtailment in longevity. So like a 12 to 15 year loss in average lifespan. And when we look at what these folks were dying of, things like cancers, circulatory disease, respiratory infections, infection was quite high. Infectious disease was quite high. But cardiovascular disease, cancers were almost unheard of. And from the paper, the overall pattern of Victorian causes of death broadly resembles that found in developing countries today, with infection, trauma, and infant mother mortality in the pole positions and non-communicable degenerative diseases being relatively insignificant. And it's another piece from that. In light of the huge body of evidence linking diet to health, many researchers are now studying the dietary intakes of different groups of people and attempting to tease out such esoteric factors such as how much omega-3 fish oil is necessary to reduce the risk of Alzheimer's, or what dose of flavonoids should be consumed to reduce the risk of stomach cancer. Most of this research is patently a waste of time. I love this paper. Current generations are, from a historical point of view, anomalous. Our historically low levels of physical activity and consequently food intake mean that even those groups consuming the highest levels of berry fruits, green leaf vegetables, or oily fish are still well below optimal mid-Victorian levels of consumption. What these folks are suggesting is that we are so sedentary that even when we find a way of eating that prevents us from being overweight, we're still so sedentary that we're not actually putting the total amount of nutrients through our system that we should. And if you think about this less like a bomb calorimeter, less like a furnace, and more like the food and nutrients that we're consuming as information packets, it makes a lot of sense. We're actually in like a nutrition information deficit in the modern world. We believe also that the ongoing search for disease susceptibility genes is ahistoric and therefore largely misinformed. The mid-Victorian gene pool was not significantly different to our own, yet their incidence of degenerative disease was approximately 90% less. And I can't agree with this more. I'm just so underwhelmed with what genetic testing has told us. There's a little bit of trends here and there, like finding some support for whether or not you're carb tolerant or not, or the likelihood of, say, like celiac disease. There might be some value in that, but genetics were supposed to revolutionize medicine. They've done nothing of the sort. And to this point, I have a piece from the website Seeker, Americans Getting Shorter Due to Bad Diet. This is a first time in history event in the whole history of the United States and other developed nations. People have historically gotten taller and healthier, and this has ceased. Kids today are on target to be shorter than what they were in the past. And really interesting side note story, Sagan and Zoe are 2.5 years apart in age. Both of them at age 4 had to go to the pediatrician for a well-child checkup. And they were both exactly the same height at the same age. But what was interesting is that Zoe, the older kid, she was in the 96th percentile for this height, whereas Sagan was in the 98th percentile. And I was looking at the numbers and I asked the doctor, I'm like, Doc, they're exactly the same height. Why would Sagan be taller? And he was kind of stumped. And then he called me back and he's like, kids are getting shorter. And this had happened enough that there was a 2, percentile delta there that occurred in 2.5 years. So this is really significant stuff. And this is, again, where like some of the folks in the, let's say, the evidence-based medicine scene that just go on and on and on defending, the calorie-centric model. Yes, calories matter, but at some point, if we make our food system such a pile of shit that, there's virtually no possibility of winning, it becomes ridiculous to continue defending that. But probably most of you are largely bought in on that, so no point to really dig in. What about Mtor? Everybody's terrified of Mtor. I highly recommend this paper from David Sabatini, 25 years of Mtor uncovering the link from nutrients to growth. It's just an amazing review paper from the guy that really, spearheaded the discovery of Mtor. But it's worth understanding that Mtor has 2 different protein complexes, and they have both complementary but also antagonistic activities. And it's worth mentioning that oxygen, glucose, amino acids, insulin can stimulate mTOR complex 1. mTOR complex 2 is stimulated by insulin and various growth factors. And again, these things play really critical roles in growth and cellular differentiation. They're very important, but the sense that I get from people is what they're being sold based off of, again, kind of calorie restriction, protein restriction research, largely in animals, is this idea that if they reduce mTOR signaling by reducing protein, insulin at large, but protein in particular, then you're going to avoid cancer at all costs. And I'll concede that maybe relative to an overfed state, reducing that scenario would probably lead to better outcomes. But this is something to keep in mind. This is a paper from the Journal of Cell Biology. Muscle inactivation of mTOR causes metabolic and dystrophin effects, leading to severe myopathy. Really curtailing mTOR activity means that you end up with a type of muscle wasting effectively, which is going to be terrible for health and longevity. And it's interesting and worth mentioning that a ketogenic diet, another paper, ketogenic diet inhibits the mammalian target of rapamycin mTOR pathway. What the ketogenic diet does is it tends to curtail mTOR expression in places like the liver and the brain and the peripheral organs, but it doesn't really alter mTOR activity in the muscles. And this is a really important distinction. It's not that you want mTOR turned on or off. You want it on and off in the right places at the right time. And again, this is just something that people have made this such a simplistic model and, suppress mTOR expression at all costs. And no, that is ridiculous. You've got to understand that mTOR complex 1 activity has to function for us to be able to identify cancer cells. If we don't have that mTOR complex 1 activity, we won't identify cancer cells. And this will allow them to go on and grow and metastasize and be far more problematic than if our system is able to clear it. Too much mTOR, too much insulin, too much food, too much calories. Yeah, you will die early. But too little, and we are sarcopenic, and you will absolutely die early. And I would go out on a limb and say, well, I don't know which one is ultimately going to be worse. I guess we could probably make the case that overfeeding is going to be worse here. But again, what this talk is for is folks that are diligently tinkering with this kind of, excuse me, I'm going to take a sip here. Folks are diligently tinkering with this ancestral health model. They're thinking about what they should eat, getting some circadian entrainment and whatnot. But I see a lot of people literally terrified of protein intake and consuming levels that are, in my opinion, very inconsistent with optimal health and longevity. And again, it's compromising your life today. And I'll go out on a limb and say it's going to compromise your life in the future as well. Chronic overfeeding of amino acids and carbs, elevated insulin are absolutely a problem. But I think you would have to try really hard within an ancestral eating context to make this a problem. Some people figure out how to still overeat on it. And, we have some nuances, like some folks like me are not particularly carb tolerant. We need to account for that. But I see people reduce this to the simplicity of a light switch being turned on or off. We should much more closely think about this like a set of piano keys. I believe there's 88 keys on a piano, and I don't know if there's actually even an upper limit to how these can be toggled. There may be more options than there are atoms in the universe or something like that. I should sit down and try to figure out, what the story is there. But nobody would argue that there's not a massive amount of complexity dealing with 88 keys on a piano. And if you want to make a decent piece of music, it's not just the sequence of the keys, but the amount of time that some of them are turned on and turned off and the pacing in between. And then we have something on the order of 20,000 genes in our body. And not all of them are turned on all the time, but that's kind of the point. Like, again, we need to think about this more like a symphony, more like a massive information processing center than just saying, well, we're just going to reduce calorie intake and everything's going to come out favorably in the wash. I don't think it is. What about fasting? Again, I was arguably one of the early people talking about fasting, and I do think that there's some benefit. There's a great paper in Cell Metabolism. Early time restricted feeding improves insulin sensitivity, blood pressure, and oxidative stress, even without weight loss in men with prediabetes. I think there's a case to be made for eating more of our calories, more of our carbs earlier in the day. I think that case is becoming stronger and stronger. This may not be the optimum for everybody, but this is kind of the most that I would recommend out of a story like this. And really what it's advocating for is, like an 8 a.m. to 2 p.m. Ideally eating window. We never pull that off. We have kids, and we actually need to do, breakfast, lunch, dinner with them and try to actually eat with them. If I lived alone, I could probably pull this off. So it's more like 9 a.m. till 4 or 5 p.m. But I feel better with this, and I think that there's pretty good research that suggests it. And I don't want to get into this too much, but when we look at the anthropological literature, there's a piece, Scant Evidence of Periodic Starvation Among Hunter-Gatherers. You don't really see much starvation until we started seeing agricultural scenarios. Even modern hunter-gatherers that live in very marginal areas, they always have some type of food around. It's not always the total amount of food that they want. It's not always the exact thing that they want, but they're so good at extracting nutrition out of their environment that there's virtually always something that can be found. Or they just pull up stakes and move somewhere else. And it was only when we started living in more fixed areas that a crop failure, for example, could become catastrophic and people could face really long-term famine. So even though I think humans should be robust and should be able to go a couple of days, without eating and not totally crater, I don't think that no better describes our normal default state than chronic overeating while sitting on a couch watching TV does. There's a very different middle ground there that exists of physical activity and circadian entrainment, nutrient density, et cetera, et cetera. But people get really geeked out about autophagy. Autophagy is really important. We probably, in the overfed state, don't have enough of it. It removes broken proteins and stimulates regeneration. But it's important to understand it removes senescent cells. And people just assume that's great. But again, this is another one of the pieces that I am absolutely perplexed that none of the big players in this longevity story talk about. Senescence isn't a binary on-off story. It's a spectrum. And for normal physiological functions to occur, we need some amount of our cellular pool to be in a quasi-senescent state. So there's the paper, short-term gain, long-term pain, the senescence life cycle, and cancer. And this paper makes the case, I'll read from it, efforts to reconcile the beneficial and detrimental features of senescence suggest that physiological functions require the transient presence of senescent cells in the tissue microenvironment. We need quasi-senescent cells to be able to carry on just normal physiological functions, including things like identifying cancer and normal cellular differentiation. So another topic that nobody talked about, and again, the folks that are listening to this via podcast, maybe you can track down a video of this at some point if it pops up. But I've got a picture here of one cell dividing into two cells going to 4 going to 8 going to 16. So normal cellular replication. I also have some representations of the telomeres on chromosomes. The telomeres are these little structures that help to manage the replication of DNA and cellular replication. What's not, this thing that I'm talking about here is the Hayflick limit, which I alluded to earlier. And again, this is one of the things that makes me crazy. The Hayflick limit is this understanding that eukaryotic cells, generally, particularly in humans, have about 50 cellular replications. Each time the cell replicates, a little bit of the telomere gets trimmed off. And once you hit about 50 replications, telomeres are gone, the cell basically goes ass up, and that's it. And what's critical to understand, we don't want a ton of senescent cells around, but we don't want no senescent cells around. And overly aggressive protein restriction, fasting, what it does is it basically reduces the pool of cells that we have available. And in animal models where animals have been subjected to serial significant protein or fasting exposures, these animals die young from multi-organ failure phenomena. And that's because there's no more stem cells left. They've all been used up because some of them enter a quasi-senescent cycle in a sufficiently vigorous autophagic stimulus, calorie restriction, protein restriction, that will cause these cells to die. And under some circumstances, we want that, but we don't want it always, all the time, which again is the way that folks are tackling this. Like, I've seen people wearing some t-shirts, body by autophagy, and it's just like, No, that's not what you have in mind. This is not the endpoint that you want. So again, Hayflick Limit, senescence, what was the other one earlier? Genetic reaction norms. These are things that I really encourage people to geek out on and get well educated about. And this is interesting too. This is from the journal Neuroscience. Ketogenic metabolism inhibits histone deacetylase and reduces oxidative stress after spinal cord injury in rats. An HDAC inhibitor is a molecule or a phenomena that slows the rate of telomere loss. So again, a ketogenic diet is really interesting in that it mitigates insulin signaling. It even mitigates some elements of inflammation. It allows for some autophagy, but maybe not too much autophagy. Excuse me. One more sip. And it's a pretty known entity. Like, you can motor along. We have a lot of known endpoints within the ketogenic diet space versus, I think that the long-term ramifications of significant amounts of fasting, like, we really don't understand that. And when I look at the mechanisms, the proposed mechanisms, it just doesn't strike me as a net win. It's worth mentioning another paper from Cell Cycle: Coffee Induces Autophagy. If you want some autophagy, drink some coffee. Exercise induces autophagy in peripheral tissues in the brain, from the journal Autophagy. Exercise mitigates the loss of muscle mass by attenuating the activation of autophagy during severe energy deficit. So this is, again, where it's really important to understand we want some of this stuff, and we want it in the place we want at the time that we want. What exercise does is curtails autophagy in our muscles. It can stimulate some too under some circumstances, but net, when we're in a calorie restricted state, we could start seeing really significant loss of muscle mass, and exercise blunts that. So it's an important thing. The fact that there's this preservation mechanism there, it should be kind of important and better understood. And like I said, too much of a good thing can be very problematic. Another paper, Two Sides of Lifespan Regulating Genes, Pro-Longevity or Anti-Longevity. What this paper talks about is the main benefit of all these interventions is improvement in insulin and IGF signaling. And again, we have some ways of really modifying that. And I think having more control versus looking at this as something that we just have to suppress wholesale, either on or off. We have a lot more dexterity than that. And, mixed into this whole story, I would make the case that biology, quote, wants us to live a relatively long time. I know that's anthropomorphizing this, but this is another thing that I don't see talked about. There's this concept that this is from the journal Gerontology, the grandmother effect, implications for studies on aging and cognition. All primates have comparatively long lives, likely due to both social and economic reasons, but humans are particularly long-lived. So we already have a remarkable selection bias towards longevity, independent of calorie restriction, and this is likely due to the reasonably complex culture that we have. So it's not to say that there aren't other things that we can do to help goose this factor, but biology has already seen that it's valuable to at least keep some grandparents around because of their ability to help with child rearing and transmit culture and things like that. And if you want to lay somebody up quickly, this is from the journal Cachexia, Sarcopenia, and Muscle. Sarcopenia and Mortality among population-based sample of community dwelling over older adults. This is basically looking at what was the relative health and functionality of folks depending on where they were in kind of the sarcopenic scale. And it's not just linear, but you fall off of a cliff with decreasing amounts of muscle mass and the ability to generate power. So this is, again, where when we're thinking about what to do, if somebody's asking the question, should I add a fourth day of strength training each week, or should I add an extra day of fasting each week? I would really lean towards the strength training, and I think that that's pretty easily defendable, because sarcopenia will kill you. You might develop cancer. We've all got a potential there. We might develop cancer. We might develop a neurodegenerative disease. I think in those stories, we understand that simply overeating, which isn't that simple in a hyperpalatable food environment, but just figuring out a way to not overeat, have some regulation of our insulin signaling, the likelihood of cancer, cardiovascular disease, neurodegenerative disease is quite low. It's not zero, but we understand pretty well that it's quite low. We all are facing a sarcopenic end state. And the thing about that is how we tackle it now will dramatically influence the vector that we're on long term. Another piece from the journal Aging and Disease, Role of Dietary Protein in Muscular Fitness and Longevity and Aging, it looks at the VO2 max and the power production of folks over the course of aging. And what's so interesting is a 70-year-old individual could have a better aerobic capacity than a comparatively sedentary 35-year-old. And a 90-year-old individual, if they strength train, could have the physical capacity of a 50-year-old. This is going to dramatically change near end of life quality of life. And again, this is something that you can have the best designed program, you can be very diligent. We all are going to experience sarcopenia, muscle loss, loss of the motor and units and whatnot. Not all of us are going to develop cancer. All of us are going to face sarcopenia. So how many of us want, to do the trade of wasting our muscle mass, not building it in the time that we can, and not fighting to maintain it with adequate protein intake and sufficient strength training stimulus? Because it's a guarantee that sarcopenia is coming for you. It is not a guarantee that cancer, cardiovascular disease, or neurodegenerative disease are coming for you. And the efforts that you put into smartly maintaining muscle mass will reduce your likelihood of all of those other diseases and a host of other things. And again, it benefits your life today. It benefits your life tomorrow. Really quickly, I know this thing's kind of getting long in the tooth, but there's a great piece from the Journal of Evolution and Health, Evolutionary Biology of Diet, Aging, and Mismatch. This is by Michael Rose. I interviewed Dr. Rose for my podcast. Brilliant man. Several evolutionary biology journals have made the case that longevity research is effectively broken into the time before and after Dr. Rose's work. And all that he recommends, he doesn't even necessarily recommend a ketogenic diet. He recommends what he calls a Trader Joe's paleo diet. You know, eat some organic produce, eat some grass-fed meat, and call it a day. Dr. Rose was also picked for the Bacon Prize for Thought Leadership and Super Longevity. I'm not really too sure what that is, but a Bacon Prize for anything seems like a good idea. So that guy's pretty smart, and he's kind of broken this whole thing down. Yeah, definitely lift weights, definitely exercise, but at about age 40, start adopting something that is a protein adequate, not overfed type of dietary practice. So a couple of takeaways. Severe calorie restriction and or fasting are unlikely to extend life and may in fact shorten it. Hopefully I've made a pretty good case around that. We don't want mTOR turned completely on all the time, but it's also, it's super silly to fear its activity. We need mTOR. We need mTOR signaling. This needs to be looked at more like a symphony, not a light switch that's turned on or off. Some degree of fasting, particularly early time restricted feeding, excuse me, again, tickle in my throat, is likely beneficial. But again, I see people going nuts on this stuff. What are some of my prescriptive? Well, before we get to the prescriptive, some amount of fasting might be beneficial for a host of reasons. But we also know that drinking coffee, lifting weights, and getting a tan, having a solid social network are known to be beneficial. And again, they benefit us today and they ostensibly benefit us tomorrow. How much would you fast? Maybe 3 days every quarter, 5 days per year, something like that. It's worth mentioning that Peter Attia has really pumped the brakes on the amount of fasting he's doing. And although he never has made it prescriptive, he's just been like, this is what I'm doing. It's always interesting to follow Peter, and he's a brilliant guy, but I would go out on a limb and say if he started more of this process from the evolutionary biology perspective and then took his brilliance and wove it more into the mechanistic weeds, I think that it would be interesting to kind of see what the process emerged like that. Yeah. So thoughts on health and longevity: don't overeat. It's a trite thing to say, but if we can pull that off in this modern hyperpalatable food environment, it can go a long ways towards helping us. Mind your circadian biology. We know that adequate sun and light exposure, the right times of day, are critical. Find an appropriate glycemic load. My 7-day carb test is a fantastic tool for that. Be mindful of immunogenic foods. This is maybe the most important thing that comes out of the paleo diet space, is this recognition that there are some foods that may be immunogenically problematic for some people. And a little bit of elimination diet, a little bit of tinkering, we can usually find this stuff. Lift some weights. I think 2 to 4 days a week doesn't need to be a ton, but it just provides enormous return on benefit or return on investment. Sauna seems awesome. Find meaning and social connections. And these things are really well established, well known to improve quality of life, and seem to correlate well with overall longevity. And again, wrapping this thing up, I could really make the case that a basic ketogenic diet approach would provide all of the upsides of all this complexity. Like, find something that looks like a protein adequate ketogenic diet. Eat the bulk of your calories earlier in the day. Maybe 2 meals a day, maybe 3, but eat the bulk of the calories early. Lift weights 2 to 4 days a week. Get some sun on your skin. Have good meaning. And that should provide all of the potential upside that we could get from really onerous interventions like calorie restriction or fasting, and with really none of the downside. And again, just to recap all this stuff, I think once one hits kind of a reasonable ancestral lifestyle, I just don't know if there's much, if any, upside in these more vigorous interventions. Maybe there is, but hopefully this at least introduced the potential that that may not be the case, and that we may be able to find easier ways to have both a better life today and ensure our health and longevity later. So as always, any questions, fire those off to me. I'm here to serve. Hope y'all are well. Take care.